welcome to today's session. In our today's session, we will discuss series feedback amplifier. Okay, in the last session we have discussed voltage amplifier, that is series shunt feedback amplifier. So, if we are going to analyze voltage amplifier easily, the remaining all topologies are very easy to understand. Okay, so in our today's session we will discuss this series feedback amplifier, which is also called as transconductance amplifier. Okay. As the name itself indicates, transconductance means output is current, input is source voltage, right? So that means in the reverse of resistance, that is I by V. So nothing but I naught gain is calculated as I naught divided by Vs. So it is open loop gain or closed loop gain. So as we have analyzed series shunt, that is voltage amplifier, by considering three important parameters, that is closed loop gain, another one is input resistance with feedback, output resistance with feedback. Same thing we are going to find out with respect to series feedback amplifier. You can observe this is also series, here also series, input is voltage and the output is current. Okay, so which is having an current source, nothing but A into Vi, right? So now we will discuss the ideal case. This circuit consists of two parts called as circuit A and circuit B. The circuit A is nothing but your open loop transconductance amplifier consisting of input resistance Ri, output resistance R0, and A, which is called as open loop gain. In this case, it is called as transconductance gain. The feedback network is consisting of beta, which is called as trans resistance gain in this case, because output current is sampled and it is going to be mixed with the input source voltage. It is going to be mixed with the input source voltage, right? So now let us start the analysis. We are going to analyze with closed loop gain first. If you are going to do voltage amplifier easily, if you understand that this three parameters are easy to understand. Now let's see AF, that is closed loop gain, which is nothing but output by input. Output is the current, that is I naught by Vs, right? So as soon as I told I naught, if you are observing, the I naught is nothing but A into Vi, because the transconductance gain, that is open loop gain, is nothing but I naught divided by Vi. Okay, so I want I naught is nothing but A into Vi. I can observe I naught is equals to A into Vi divided by, now Vs, this we have already discussed. Vs is nothing but Vi plus Vf, which is equal to A into Vi divided by Vi plus, what is Vf? Vf is nothing but beta into I naught. In voltage amplifier it was beta into V naught, now it is beta into I naught. Beta into I naught. Okay, so now next is A into Vi plus, so what is I naught? That is I naught is again A into Vi. I replace that, I will take common Vi get cancels. You are going to observe, I got feedback gain is nothing but A divided by 1 plus A beta. That means this particular topology satisfies the negative feedback structure, right? So now come to the second one. This is an equivalent circuit. The second circuit is an equivalent circuit consisting of input resistance with feedback, output resistance with feedback, and you can observe AF, that is closed loop gain. The equivalent circuit of this ideal case is observed over here, which is having an input current II, an output current I naught, and input source voltage Vs, right? So now you just observe RAF is nothing but input resistance with feedback, defined as V by I. V is Vs divided by II. So what is II from this particular ideal case? II is nothing but Vi by Ri. Same thing I have written. So Ri comes here, Vs by Vi. Now Vs is nothing but Vi plus Vf divided by Vi. So if you observe this particular output RIF, we have got Ri into 1 plus A into beta, same as voltage amplifier, right? There is no change at all. It is same as voltage amplifier. Now come to the third one. This is the most important one. This change from voltage amplifier, that is output resistance with feedback. So there we have considered Thevenin's equivalent circuit. Here we are considering an equivalent circuit, as current is series. Current is connected series, that is output current is going to be sampled in the form of series. So we are going to consider an test current which is obtained from breaking the circuit, due to which I am going to get a terminal voltage called as V. Okay, so now you can observe RYF is equal to V by I. So V divided by I is nothing but test current, that is IT. Okay, where V is defined as voltage across this particular circuit. So voltage across this particular circuit is nothing but V is nothing but I into R. The I is IT minus A into VI. IT minus A into VI multiplied with R0. So this is the definition of the special voltage, terminal voltage, because of obtained at breaking the circuit. Okay, so as we know that for the analysis of output resistance, input should be made 0. I am observing Vs as 0. So as soon as Vs is 0, this particular equation Vs equal to Vi minus plus Vf becomes Vi is equal to minus Vf. So what is Vf? You know, you have got beta into I naught. Beta into I naught. So beta into I naught is nothing but IT. I naught is nothing but minus beta into IT. Okay. So now I am substituting this particular thing in the equation of V. V is equals to IT minus Vi means minus into minus plus A beta into IT is going to be obtained multiplied with R0. Okay. So now IT is common. I will take it out. I will send it to the denominator of the LHS. So you get V by IT is equal to R0 into 1 plus A beta. So now you can observe V by IT is nothing but defined as output resistance with feedback. So same thing I have obtained, R0 of F is equal to R0 into 1 plus A beta. Okay. So if you observe input resistance with feedback and output resistance with feedback, here both are going to be increased by an amount of 1 plus A beta. In voltage amplifier, input resistance was high, output resistance was low, but in this case, that is transconductance amplifier, input resistance is also high, output resistance is also high, right? So now we have obtained negative feedback structure, that is feedback gain A by 1 plus A beta, input resistance is increased by 1 plus A beta, output resistance with feedback is increased by 1 plus A beta, right? So I hope you have understood this series feedback amplifier. In the next session, we will discuss the next amplifier part. Thank you.